So we're going to continue with taking derivatives and look at some rules, some more shortcuts. So we have f of x here, and we can rewrite it as a cubic function. In other words, multiply it all out to put it in polynomial form. So let's go ahead and do that. If I distribute, I would get 2x times x squared, which is 2x cubed. 2x times negative 2x is negative 4x squared. 2x times 1 is 2x. So we distributed the 2x. Now I want to distribute the negative 3. So negative 3 times x squared, negative 3 times negative 2x, and then negative 3 times 1. And then we can combine like terms. 2x cubed, negative 4x squared, and negative 3x squared. We've got negative 7x squared, 8x, and a negative 3 at the end. So we remember how to take the derivative of a polynomial. We're going to apply the power rule. 3 times 2 is 6. X squared. It's going to give me negative 14 x to the 1 power plus 8. And this is the function that is the function of our derivative. Now let's remember what that is. This is the equation that can be used to find the slope of any tangent line drawn to f of x at any value of x. So if we plug in an x value, we get the slope of that tangent line at that point. Now, there were two men that are credited for developing the study of calculus. That's Isaac Newton and Gottfried Leibniz. And in 1673, Leibniz published an article which he concluded with the product rule of differentiation. So the product rule says if we have some function, h of x, that is made up of f of x times g of x, we have a product of two functions, then h prime can be found by finding the derivative of the first function. I'm going to try to color code it, times g of x in its natural state, plus the original function f of x times the derivative of g of x. So it's the derivative of the first function times the second, plus the first function times the derivative of the second. So let's apply that to the one we just found. So if we do that, we are going to call 2x minus 3 is going to be our f of x. And that means x squared minus 2x plus 1 would be g of x. So if we use this rule, and this was actually function f, so this is still f prime. The derivative of the first is just 2. Derivative of 2x minus 3 is just going to be a 2. Times the second function just as it is, plus f of x in its original state. Now we're going to take the derivative of g of x. So that's 2x minus 2. Let's see what happens when I multiply that out. So when I distribute the 2, I'll get 2x squared minus 4x plus 2. Over here, 2x times 2x is 4x squared. 2x times negative 2 is negative 4x. Negative 3 times 2 is negative 6x. And negative 3 times negative 2 is positive 6. Let's combine like terms. So I've got 2x squared and 4x squared, that's 6x squared. Negative 4x, and a negative 6x, that's a total of negative 14x. 2 and a 6, that's an 8. Well, that's awesome. I mean, that was actually less steps, right? So why in the world would I want to do that? Well, there are times like this, x squared sine x. I can't distribute that. I cannot rewrite that as a polynomial. The only way I could take the derivative of it is to actually use the product rule. So let's see how it's going to work. So g of x is x squared times sine x. So x squared, oh, I changed colors up, but that's okay, times sine x. So we're going to apply this new rule and find g prime, the derivative of the first. So the derivative of the first function is 2x times sine x. Plus the first times the derivative of the second. And the derivative of sine is cosine. Now, can we use this to find the slope of the normal line when x equals pi? Well, great. Yeah, normal, that's perpendicular to the tangent. So I need to find the slope of the tangent line. Well, the slope of the tangent line is found by g prime evaluated at that x value. So I need to plug in pi. So that's 2 pi times the sine of pi plus pi squared times cosine pi. Well, sine of pi is 0. And cosine of pi is negative 1. So I'm left with negative pi squared. Now let's remember what that is. That's the slope of the tangent line at x equals pi. So how would I find the slope of the normal line? At x equals pi. Well, it's just going to be the negative reciprocal. So this was negative, it's going to turn positive and flip it. So the next page, we have some practice problems on it. Just practicing finding the derivative. So, to find the derivative, I think I'm just going to stick with one color. No, I'll color code. The derivative of the first here's the first, is 4x plus 3 times the second, just like it is, plus the first in its originality times the derivative of the second. Now I'm going to pretty that up a little bit, just because that doesn't look pretty to me. And remember, there's times to simplify your answer and there's times not to. For this practice, we're going to practice simplifying. So 4x times x squared is 4x cubed. Then I'd have negative 12x plus 3x squared minus 9. Distribute here. That's plus 4x cubed plus 6x squared. Combine like terms. And I get 8x cubes. There's a 4x cubed and another 4x cubed. 3x squared and 6x squared, that's 9x squared. A negative 12x and a minus 9. For this one, it may be helpful to rewrite the square root of x as x to the 1/2 power. Now I know I could distribute and I'd be dealing with a whole bunch of weird radicals and stuff like that. So power rule comes in handy. Not power rule, product rule. G prime of x equals the derivative of the first times the second plus, whoops, that should have been negative 1/2. Oh, I hope you caught that. Plus the original first times the derivative of the second. Now, if all they asked for really was to find the derivative, I mean, we've done it. The rest would be just simplification, which I know does come in handy sometimes. So if I distribute, I'd get 1/2. This is like having 4 halves plus negative 1/2 is 3 halves. And then this would be minus 1/2 times 3 is 3 halves. This is like a 2 over 2. So that's going to be x to the 1/2. Plus 1/2 times 2 is 1. X to the negative 1/2. Distribute here, and you get 2x to the 3 halves minus 3x to the 1/2. Combine like terms, and I've got 5 halves, x to the 3 half, and then that'd be 6 halves, so minus 9 halves, x to the 1/2. And then this is the only one with that exponent. And personally, I'd be fine with that answer. Product rule. First function is x cubed. Derivative is 3x squared times the second, just like it is, plus the first unchanged times the derivative of the second. Love it. H prime, derivative of the first is just a 3 times the second, just like it stands, plus 3x plus 2 times the derivative of cosine, which is negative sine. Ooh, this one's not a product. At least not yet. Let's see what we can do. Can I rewrite that? Wait, got an idea. What's the derivative of 3 theta? And this should have been a theta. Sorry, theta. Derivative of 3 theta is just a 3. This I can use the product rule on. So derivative of theta would be 1 times sine, just like it is, plus theta in its originality times the derivative of sine, which is cosine. Ooh, that's nice. How about over here? The derivative of sine is cosine times cosine plus sine times the derivative of cosine. That's cosine squared. And that's going to be minus sine squared. That turned out kind of neat.